6.4 is going to talk about adding and subtracting rationals. And so anytime we say the word rational or rational expression in math, we're going to be referring to fractions. And so I want you to recall that when you add or subtract fractions, that requires you to have a common denominator. And so all that means is you're going to find the LCD before you add or subtract them. And so only like terms can be added or subtracted in math, and fractions are like when their denominators are the same. And so just to give you a quick little example here, if I gave you 1/2 plus 1/4, okay, you cannot just add them straight across like this. That is a no. You cannot do that. So no, can't do this. This is where you're going to have to find your LCD and make sure that the denominators are the same. And so what I went ahead and did for you is wrote down a bunch of steps here that will essentially be the same exact process that you're going to do every single time when you add or subtract rational expressions. And so the first step says to find a common denominator, so find your LCD. Second step says to rewrite each expression, and this is where you're going to have to change each expression so they have the same denominator. And then that essentially means you're multiplying each fraction by, and I put the 1 in quotes here. What I mean by that is you might have something like 2/2, 2/2, or something like x minus 3 over x minus 3, and so forth. All right, third step, you need to make sure you combine the numerators, and this is where you're going to add or subtract the tops. And then the last part is to simplify. So you have to make sure your answer is in the lowest term. So you need to make sure you simplify. And so following all these steps, let's go ahead and look at this first example right here. So it says 4x over x plus 2 minus 2 over x plus 2. Well, first you want to check and see, are your denominators the same? If they're the same, you can skip steps 1 and 2 and just go straight to step 3. So for this example, your denominators are the same. We don't have to worry about finding a least common denominator. And so I'm just going to go ahead and rewrite that x plus 2 in the bottom. And so now you can go ahead and combine the numerators. And so you're going to have 4x minus 2 on the top. So you basically just want one big fraction here. And so now we're going to go to the last step where you simplify. And so this is where you're probably going to have to factor something. So you need to check and make sure that you can factor everything properly. Okay, and so the top part, I can take out a GCF of 2. And so when I do that, I'm left with 2 times 4x divided by 2 is 2x minus 2 divided by 2, which is 1. And so here we are left with 2 times 2x minus 1 over x plus 2. And so we can't do anything else with that, so this would be your final answer for this problem. Okay, so again, we're following these 4 steps, and if you don't have to find the LCD, you can just skip to step 3. Okay, so let's go ahead and do another example. So we have this example right here. So again, check to see, are your denominators the same? You have an r minus 5 on the first one, and an r minus 5 on the second one. So they are the same, and we are good. So all you have to do is rewrite the denominator, and then you just combine the numerators now. So we're going to step 3, and you just want everything to be in one big fraction. I think my pen is being all wonky. All right, so again, because we're dealing with rational expressions, you're gonna have to factor something. And so for that top part, we will have to factor. And so what I'll do is I'll put my work over here on the side so you can see how we're factoring. Again, you will be factoring a bunch this unit, so again, it's gonna help brush up those techniques. And so we have a trinomial. You wanna go ahead and find your factors of 15, So 1 times 15, 2 times, nope, you can't do 2, 3 times 5. All right, you want to see which one is going to add to give you a negative 8. And so from here, I know that 1 plus 15 won't give me that. 3 plus 5 gives you 8, but we need a negative, so it has to be negative 3 plus negative 5 to give you that. And so we're going to go ahead and set up our pairs of parentheses. So we have r and r because we have r squared. We said minus 3 minus 5. Okay, so we found the factors. So I'm going to rewrite my polynomial on the top as r minus 3 times r minus 5 over r minus 5. And then from here you can see that we can cancel something out. And so when we simplify, your r minus 5s go away, and all you're left with is r minus 3. All right, so again, we did not have to find the LCD for this example as well because the denominators were the same. All right, let's see if we have another example. All right, look at this one. So we have p over 8 plus 4 over 5. So right off the bat, I can see that my 8 and 5, they're not the same thing. So your denominators are not the same. So this is where we're going to have to go back to step 1, and we need to find your LCD. All right, and so we just have numbers on the bottom, and so when you do that, all you have to do is list out the multiples. And so when you do the multiples, again, it's going to just be whatever this number is times another. So 8 times 1 is 8, 8 times 2 is 16, 8 times 3, 24, 8 times 4, 32, 8 times 5 is 40, 8 times 6, 48, I'll go up to that. All right, and then you do the same thing for 5. So 5 times 1 is 5, 5 times 2 is 10, 15, 20, 25, 30, 35, 40, 45, 50. I'll go up to there much. All right, and we can see that, what do they have in common? That's the smallest number, 40. So 40 is going to be your LCD. So that is step 1. All right, step 2 now, and let me go ahead and move this so that way I have some room. Step 2 is where you have to change the expression or rewrite it. And so basically, I want my 8 right here to look like this 40. So how do I make an 8 turn into a 40? Well, I know I have to multiply 8 by 5 to get that. But then again, we are multiplying by that 1. So multiply by 1. So in this case, 5 over 5 equals 1. So I need to multiply both the top and the bottom by that. Because again, you can't just do the denominator. You have to make sure you do it to the top as well. And so you do the same thing to the other side. What can you multiply 5 by so that way it looks like a 40? Well, I can multiply it by 8. So I'm going to have 8 over 8 on that fraction. All right, and so after you do that, you want to go ahead and just multiply those two together. So I'm going to focus section by section, so let's just look at this side first. So you want to distribute. So 5 times p is just 5p. And then 5 times 8, that gives you the 40 on the bottom. We're going to go ahead and do the other fraction. So again, 4 times 8 is 32. And then 5 times 8 is 40. And that is step 2, where you go ahead and rewrite that expression. All right, step 3 is where you just combine the numerators. So 5p plus 32. We can't really do anything with that. You can't combine any like terms, so you just kind of put them together in one big fraction. And then you put it over 40. And then if you can simplify this, simplify this. I don't think we can, so the simplified answer is going to be just that. So 5p plus 32 over 40. All right. So that was that example. Let's go ahead and do another one. So again, step 1, check to see are your denominators the same. This one is not, so we need to find an LCD. So again, we just have numbers here. So list out your multiples of 4 and 6. So 4 times 2 is 8, 4 times 3 is 12, 4 times 4 is 16. All right, 6 times 1 is 6, 6 times 2 is 12. Ooh, there it is. So we have 12 and 12. So 12 is going to be the LCD. So that was step 1. All right, step 2, again, we are going to multiply both fractions by something, so by 1 essentially, but it just depends on what the number is on the bottom. So let me move this over real quick. All right, so how do I get this 4 to look like a 12? You need to multiply by 3, but again, whatever you do to the bottom, you got to make sure you do it to the top. All right, and then how can you make this 6 look like a 12? Well, if I multiply it by 2, that'll give me 12. So again, whatever you do to the bottom, you make sure you do it to the top. That was step 2. Step 3, let's go ahead and distribute these in. So 3 times 2x is 6x. 3 times negative 6 is negative 18, all over 3 times 4, which is 12. All right, there's the first fraction. Second fraction, 2 times x is 2x, 2 times 5 is 10, all over 6 times 2, which is 12. All right, and now you're going to go ahead and combine the numerators. So you can go ahead if you want. If you want to simplify straight across, you can, or if you want to put it into one big fraction, that also is fine. So if you do that, oh my goodness. This is what you're going to have. All right, and then you can go ahead and simplify. So 6x plus 2x, that will be 8x. Negative 18 plus 10, that is negative 8, all over 12. All right, and so again, check to see, can you factor anything before you simplify? So yes, we can. This, you can take out a GCF of 8. And so when you do that, you are left with 8x divided by 8 is x, minus 8 divided by 8, which is 1, over 12. All right, and then see if you can reduce anything while you're at it. So I know I can reduce 8 over 12. Let's see, by 4. So if I do 8 divided by 4, that becomes 2. 12 divided by 4 is 3. So you're going to have 2 times x minus 1 over 3. All right, and there's your answer for that problem. So again, the steps are very similar every single time. Let's go ahead and do this example now. So this is now we're dealing with expressions. We're dealing with these polynomials here. So I know right off the bat x minus 1 and x squared minus 1 are not the same. And so before we find the LCD, I want to go ahead and factor the bottom. So when you do that, that just makes it easier to see what we're dealing with. So if I were to factor the bottom, remember that is a binomial. So you can do your difference of squares. So again, difference of squares. And then when you did that, you would have to take the square root of both terms right here. And when you did that, you would get x and 1. And you just put it into that formula. So you're going to have x plus 1, x minus 1. All right, and so if I rewrite the problem, you're dealing with 2x over x minus 1 plus negative 4 over x plus 1 times x minus 1. Now we can go ahead and find your LCD. And so LCD here, when you're dealing with expressions, you want to find the one that they have in common first. So what do they have in common? They have an x minus 1. All right. And so what they're missing sorry, on my pen. What they're missing is that x plus 1. And so that is your least common denominator. And so now we're going to go ahead and do step 2 where you rewrite your expressions. And so here I know I can multiply this by x plus 1 over x plus 1 because that's what it's missing. And so we're going to go ahead and distribute these. I don't have to worry about the second fraction because it already has that denominator on the bottom. And so we're going to go ahead, distribute. You're going to be having 2x squared. So 2x times x is 2x squared plus 2x over x plus 1, x minus 1, plus negative 4 over that same denominator. All right, and so if I put everything together in one big fraction, you get 2x squared plus 2x minus 4 over x plus 1, x minus 1. All right, I need to move some stuff real quick because I don't have enough room. And so now we're going to go ahead and check to see, can you simplify this? And so 2x squared plus 2x minus 4. Again, here you're going to check to see, can you factor this? And so I'm going to move that work over here to the side. So 2x squared plus 2x minus 4. So I know I can take out a GCF of 2. All right, so when I do that, I'm essentially dividing each term by 2 so I can get that GCF out. So what's left over is x squared plus x minus 2. And then now you're going to check and see, can you factor this? So what are your factors of 2? We only got 1 and 2. That's going to subtract to give you a 1. And so we're going to have 2 times x, let's see, plus 2 because that's a positive x minus 1. So now that you have that factored, you can go ahead and rewrite that for the numerator on the top. So you have 2 times x plus 2 times x minus 1 over x plus 1, x minus 1. All right, and then from here we can see we can cancel out those x minus 1s. So you're left with 2 times x plus 2 over x plus 1 as the final answer. So that one took a little bit more work because we had to do a bunch of factoring. All right, what other examples do we have here? All right, let's look at this one. So look at what we have on the bottom. So again, before you try to find your your LCD, we're going to have to factor these. All right, and so to the side, I'll go ahead and factor these for you real quick. So x squared minus 16, that gives you, let's see, x plus 4, x minus 4. And then for this one, x squared plus 8x plus 16. If I factored that, what is that going to be? X plus 4, x plus 4. All right, so those are the bottoms factored out. So I'm going to rewrite my fractions. So 2x over this one right here. So x plus 4, x minus 4, minus 3 over this one. So x plus 4, x plus 4. All right, and so we have to check and see what do they have in common. So your LCD is going to be what? So what do they have in common? Well, they have, I'll highlight it. We have an x plus 4 in common. So they have an x plus 4 in common. And what's left over? What is not listed there? So not common. Oh my goodness. Not common. Guys, there's something wrong with my pen. Not common. Let's see, we're missing an x minus 4, and we're also missing an x plus 4. So we have that, so x plus 4, x plus 4, x minus 4. All right, and so to find the LCD, you're going to rewrite what they have in common first. So it's x plus 4. And then you write basically all of this. So we have another x plus 4. Oh my goodness. X plus 4. X minus 4. So that right there is your LCD. All right, and so what we have to do now is multiply what we're missing. So this fraction is missing an x plus 4. And this one is missing a x minus 4. So I'm going to go ahead and just rewrite my denominator. So we have x plus 4 times x plus 4 times x minus 4. All right. I'm going to go ahead and just rewrite it for all of it real quick. And so go ahead and distribute this. So 2x times x is 2x squared. 2x times 4 is 8x. 3 times x is 3x. 3 times negative 4, let me write that nicer. 3 times x is 3x. 3 times negative 4 is negative 12. All right, let me move these real quick. I don't have enough room, so let me move this up a little bit. All right, so, let's move that like this. Okay. So we're going to go ahead and just combine the top. And now here's what I want to mention. We haven't really done a subtraction problem yet. And so you are not just subtracting this 3x. We are subtracting this whole thing right here. Okay, and so I'm going to rewrite the bottom again. So we have x plus 4 times x plus 4 times x minus 4 over 2x squared plus 8x minus, okay, again, you're going to have to distribute. Again, we have like an implied 1. So distribute that negative into that numerator. So negative 1 times positive 3x is going to be minus 3x. Negative 1 times negative 12 is plus 12. All right, and then you're going to go ahead and combine everything together. So we have 2x squared. 8x minus 3x is 5x plus 12 over x plus 4, x plus 4, x minus 4. All right, and so from there, check to see, can you factor this? Let's see, if I distribute that, I'm going to go ahead and factor this for you real quick on the side. So here we have to do the MAC method. So we have x squared plus 5x plus, what is this? 2 times 12 is 24. What are your factors of 24? That will give you a 5. We got what? 1, 24, 2, and 12, 3, and 8. 3 and 8 won't give you it will give you a 5. Sorry, y'all. 3 and 8, 4 and 6. I think that's it. That's all we can do for this one. So let's see. Because that is a plus. That is a plus. Yep. Can't do anything to it. So this is your final answer for this one. All right, so you always want to check to see if you can factor. Now I'll have to look back over that. I want you to go ahead and try these problems right here. and you're more than welcome to check yourself and go from there.